All right, you guys, I want to show one more problem here using our rational root theorem. We're going to go make a list right here. We're going to make a list of all the factors of the constant, which are going to be positive, negative, 1, 3, and 9 are all factors of 9. And this time we're going to go and make a list of all the factors of the leading coefficient on the bottom. And it's not going to be just 1. It's going to be both positive and negative 1 and 2. So if I complete my list, right, my list of possibles, I'm going to get this. I'm going to get 1 over 1, which is just 1. And again, this is still positive or negative. I'm going to get 3 over 1. And I'm going to get 9 over 1. All positive and negative. I'm also going to get these with the same numerators over this denominator. So I'm going to get positive and negative 1/2, positive and negative 3/2, and positive and negative 9/2. Now we're going to run a test on those. Our goal is to find some roots, right? We want some roots that x-intercepts root solutions. So I'm going to go ahead and I'm going to make a little box and we're going to do a little bit in our head. I'm going to come over here, right? And we will list, and let's see if there's any gaps if I was going to do this with synthetic division. All right. So it looks like I go 4th, 3rd, 2nd, 1st. So my coefficients are 2, 1, negative 19, negative 9, and 9. All right. And I'm going to test my factors on that. All right. So let's start testing the list of our possible roots. So let's start with these guys, 1, 3, and 9. And then I'm going to go negative 1 and see if some of those work. So I'm going to try to stay away from our fractions. Our goal is to find 2 of these guys because I'm pretty confident that if we can find 2 of them right there, then I should be able to factor because I know how to factor quadratics pretty well. So if I can find 2, I'll divide them out of there and I'll be able to factor. So I drop this 2. 2 times 1 is 2 plus 1 is 3. 3 times 1 is 3 plus negative 19 is negative 16. Negative 16 times 1 is negative 16 plus negative 9 is negative 25. And I can already see negative 25 and negative 16 again. It's got a remainder, so it's not a root. So I go to my next. I drop the 2. 3 times 2 is 6 plus 1 is 7. 3 times 7 is 21, looking promising because I get in small numbers. Let's see what happens. Plus negative 19 is 2. 3 times 2 is 6, plus negative 9 is negative 3, and lo and behold, look what happens. 3 times negative 3 is negative 9, plus 9 is 0. I have a root. I'm going to put a little check to mark it. All right. And I'm going to come check the rest of these really quick. I'd like to find at least 2. All right. That's a 4th degree. If I can find 2, then I'll be able to divide them out and make myself a quadratic equation. So I drop my 2. 9 times 2, 18 plus 1 is 19. 9 times 9 is a huge number. In fact, I'm going to anticipate that no, this number's way too big. I've got what? 81, 100, wow, I'm up to 170. Wow, that's 171. Even subtracting that, we're looking at what, minus 20 plus 1, so 150, 152. This number's way too big. It's never going to get small enough to turn into 0 because I've multiplied 9 by 152. So no one is too big. I'm going to skip down to this one and see how it goes. All right, I drop my 2. Negative 1 times 2 is negative 2, plus 1 is negative 1. Negative 1 times negative 1 is 1. Plus negative 19 is negative 18. This gives me positive 18. Add negative 9, I get 9. Negative 9 plus 9 is 0. And there's my other root. All right. So I'm going to use these 2 roots, and I'm going to find other roots by factoring now if possible. I probably don't have to do any more division. So I'm going to list my factors. List factors. So one of my roots is 3, so my factor is x minus 3. One of my roots is negative 1, so that gives me a factor of x plus 1. All right. And then I'm going to come over here, and I want to rewrite this. Once I divided 3 out, remember it started as a 4th power, so if I just use this as a division, that gives me 2x cubed plus 7x squared plus 2x minus 3. And that's with this factor divided out. So now I'm going to divide by this factor, and I'm going to see what's remaining. So I'm going to divide by this root, which is -1. I'm going to divide into these coefficients, 2, 7, 2, -3. And if I'm correct, right, if it is in fact a root, I should get no remainder again. So I drop my 2, multiply by that, it's -2, I add. Multiply by -1, it's -5, I add. Multiply by -1, it's 3, and once again I get no remainder. Again, I've dropped all of these by an exponent of 1, right? So that's now 2x squared plus 5x minus 3. And I'm going to think about it. I'm going to do the AC method here real quick and see if I can factor this by hand. I know something that multiplies to -6 and adds up to 5, right? That's my B factor, adds up to 5. And that would be, let me think about it. That's going to be -6 and 1. I multiply to -6 and add up to 5. So it's got to be +6 and -1, or they wouldn't add up to a +5. All right. So I'm going to split my middle term. So that's 2x squared plus 6x. I'm going to put that in parentheses. And then I'm going to use this other factor, which is -x minus 3. Factor out my 2x here, which gives me x plus 3. And I need to turn this into an x plus 3. So I'm going to have to factor out a -1, which gives me x plus 3. And so my factors are 2x minus 1 and x plus 3. I'm just going to point out that these would in fact be listed roots. If I solve this guy, I'd get a -3 right there. And I solve this factor, if I set it equal to 0, add 1, divide by 2, I'd get that 1/2 right there. So they are in our list, but very often it's quicker to just kind of factor them out. So I'm going to go over here and I'm going to say 2x minus 1. I'm going to come right here and say x plus 3. I'm going to list all of this as p of x, and now we have successfully factored a 4th degree equation, all right, with actually no initial information. We didn't have a factor to start off. We didn't have anything to test. We used the rational root theorem to get ourselves a list and then divided them all out, and we have now factored 4th degree. I'm going to save this. You guys have a fun time trying this on your own.